Let's find the area of the region or regions created by the graphs of f of y equals what? It's not f of x? Haha, okay. The way you think about graphs changes right now. When we graph a function, we generally graph as a function of x. Now we're graphing as a function of y. So our perspective on things is going to need to change. So no longer are we looking at things, this is me. No longer are we looking at things, I'm happy, this direction. When we draw this next graph, if we want it to look somewhat normal, and there's going to be some backwardness to it still, we'll tilt our head, okay? So bear with me as we tackle this next one. All right, we're going to sketch a graph. It is not going to be pretty or perfect, but that's okay. I'm going to make it as nice as I can with a good straight ruler, as opposed to a crooked ruler. That would be bad. Crooked ruler, would that be like a dictator? That ruler is so crooked. All right, let's mark a few things. We know we need to go to 3 and 5, so let's do that. So 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, and we don't need this, but I'll write it anyway. 4, 5. We'll do that. So I'm going to switch to pencil because I'm likely to make a mistake. We actually know how to graph that one already. All right, so this is a parabola that has y squared, not x squared. Let me pause here. I'm going to say this. If you want to, you could really say that this equation says x equals negative y squared plus 5. And this one is x equals 3 minus y. And it is all kinds of crazy in the way we're looking at it. All right? But this one is doable. It's graphable just the way it is, right? So it's a parabola that is opening left to right because we have x to the first power. The y is squared. The leading coefficient is negative, so it's going to open to the left. And it has a shift of 5, okay? So this is a point. If you don't believe me, trust me, it is. When y is 0, x is 5. So the point 5, 0 is a thing. And then the parabola comes down about like that. And I know where it's going, so I'm really meticulous about the way I'm drawing it. Still not perfect, but fairly decent. Okay, it actually crosses between 2 and 3 on the y-axis. And the reason why, in case you care, on the y-axis, x would be 0. So I'm going to write this lightly. No, I'll do it this better. On the y-axis, x would be 0. So 0 equals negative y squared plus 5. And we would move that over, and we would take the square root. Square root of 5 is 2.2 something, right? Okay, there we go. We're going to graph this one as well, and this one is pretty solvable for y. So is this one, but then we end up with a square root function that's, same kind of thing anyway. So if you wanted to, you could say that this is equivalent to, it's not a smiley face, it's an arrow. It is equivalent to y equals negative x plus 3. And I'm just moving the y to this side and the x to the other side. You've seen this before. Okay, so what we're going to do is graph that. So it goes up to 3 and it has a slope of negative 1, and there it is. And I want to find the area of the region or regions created by the graph of f and g. So there's only one region, and it's this. And I'm going to figure out what it is. So here's what I need. I need an interval. Okay, so where's my smiley face? There we go. Normally I look at graphs like this, and I say, hey, look at that graph. Isn't that neat? But now I have to look at the graph like this. Not from the top of my head, actually. Flip it over and look at it like that. And it's still a little backwards. So I need to know where this coordinate is and where this coordinate is, and we're going to find it, and it's going to be really easy to do, surprisingly. So what we're going to do is set these two equal to each other, and that'll give us the coordinates where they meet, and that'll help us get our interval for our integral. So I'm going to say x equals this and x equals that. I don't need this one. Not anymore. So if x equals this and x equals that, then, well, this equals that, and we'll solve it. And it's quadratic, and you've been doing this for forever. So let's move everything to one side. So y squared minus y minus 2 equals 0. 0 equals, we'll factor y minus 2, y plus 1. So y equals negative 1, and y equals positive 2. Whoops, why did I put a parenthesis there? I don't know. Where's my whiteout? There it is. I found it. There we go. White that out. So y equals negative 1 and positive 2. So let's come over here to our graph. This is at the point something comma negative 1, and this is at something comma positive 2. And I can figure that out very easily. Don't think too hard. You can probably kind of eyeball it from the graph if you drew your graph very well. But let's plug it in. Let's plug in a y, and we'll figure out the x. If I have a negative 1 here, 3 minus negative 1, this gives me a 4. Actually, I don't need that, but I'm going to go with it anyway. And it's a waste of time on the AP test, but it's a good idea for now. So if I plug a 2 right here, we have 3 minus 2, so I have 1. All right. So up until this point, all my graphs have looked normal, and this one doesn't. So no longer am I dealing with an interval that is defined by x values. Now I'm dealing with an interval that's defined by y values, and my interval goes from negative 1 to 2. All right, so I'm going to go ahead and start writing my integral with my interval, and my integral goes from negative 1 to 2. And it's always top minus bottom. Well, notice the way I'm looking at it now. So when I'm looking at it like this, the parabola's on the top, the line's on the bottom. Okay? So parabola's on the top, line is on the bottom. I'm writing it wrong, and I'm going to fix it. All right? I have done two things drastically wrong. Here's what's right about it. Negative 1 to 2. We're good. Our interval is good. dy is good. It doesn't need to be dx. It is dy. We are integrating with respect to y. Here's mistake number 1. Boom, boom. And here is mistake number 2, and I left it out on purpose because it is such an easy mistake. A lot of people make it. We're subtracting this entire function, all right? Be careful with that. Please be careful with that. If you really want to get meticulous, you could put parentheses there. Not necessary, but you could. Now, you could say this is f of y and this is g of y, but when you type them in the calculator, you would have to use x's instead of y's. That's fine. It works. But I personally like to be consistent with the variables they use. So I'm going to type this in the calculator with y's. So I'm not going to use the y equals stuff and type in like functions the way we're used to seeing them. All right, we could do this one by hand. We can actually simplify it. You know what? Let's not do the whole thing by hand, but just it's a good idea just to say, you know what, I know that's negative y squared, negative, negative, that's positive y, and 5 minus 3 is 2, because they being test makers, might just say, which one of these is equivalent to the area, and I just want you, I mean, you know the algebra, you got it, but I just want you to realize that sometimes you can simplify things before you start typing. Not always necessary, but it's not a bad idea, unless it wastes your time. So, math 9, negative 1 to 2, use x if you want. I don't want to. I want to use y because that's the variable they gave me. Personal preference. I like to be consistent. There we go. That's not it. Man, I'm having a hard time here. I don't need that y there. Fingers are getting in the way. There it is. 4.5. We have found it. That's your first graph that was sideways.